What's up, fellow polymaths? In this video of the Java Fundamentals tutorial, we'll be going over variables and data types. Variables are a reserved area of memory that hold a value in a Java class. You can think of variables like a box. So for example, a box can contain anything, whatever you can think of. So the variable's signature syntax is the data type, then the variable name, and then you assign that to a value, of course with a semicolon at the end. So for example, we have a data type of string, and then our variable name is called name, and then we're going to assign that name to a value called Mario in quotes, because strings always end in quotes, and then with the semicolon at the end of the statement. So we can try this example right now in our IDE editor. So over in Eclipse IDE, we can assign a variable. So we call this string name equals Mario, and then we want to output that value by doing system out println, and then after that we just run this code. And as we see here, we have our value that was output from this println statement, the variable name. There are three types of variables in Java. There are instance variables, local variables, and also static, and they're also called class variables. Instance variables are declared outside the body of a method, but inside the class. Instance variables are not declared as static. They're not shared among instances. Instance variables are given a value, which is called instant initialization, when the class is instantiated. Access modifiers such as public, private, and protected can be a part of instance variables, and we'll be going over access modifiers in a later tutorial. Instance variables have default values. So for example, the integers, the byte, short, and int variables have a default value of 0. Instance variables can be accessed from inside any method, constructor, or block of code from that same class it was declared from. So example, right here, we have a class called main, and we have a variable that's an integer, and it's assigned as 100. So this will be an example of an instance variable. It's inside the class, basically. Local variables are variables that are declared in the body of a method, constructor, or any other block of code. Local variables are completely hidden from other methods in that same class. Local variables are initialized within the method, and the variables in the method are destroyed when the method has ran. So basically, whenever you call a method, the variables are used, and then once the method has been complete, then those variables come to an end. Local variables can be defined with a static keyword or any other access modifier such as public, private, or protected. And unlike instance variables, local variables need to be assigned an initial value before being used. So we have this example of a method called say catchphrase, which doesn't return anything because of the void keyword. And then it has a variable that's a string called word. And then we have an assignment saying, it's a me. And then we output that variable in the println statement. So we'll go over local variables in more detail when methods are discussed, but I'll show you an example of this method being called. So here we go back to our IDE, and we want to create this variable outside this main method, but inside the class. So for example, we have this public void say catchphrase, and we don't have any parameters. And parameters are basically the variables that you input in between these parentheses, and that's something we'll also be going over in a later tutorial. So we have our variable that's a string, and we want to call the catchphrase, or output the catchphrase. So we'll call our variable words, and then we'll type in it's a me. And then our output will be the words variable. So then when we want to call this, we comment this out. So we have to create an object. That's also something we'll be going over in another tutorial, so just hold on tight. So we're going to be creating an object called main, which is derived from the main class. Then we're going to call that method we just created, say catchphrase, and then we'll run this program, as you'll be able to see the result here. And you see it's a me is being called. So this is the local variable, and then local variables are always going to be in the method, which is why they're local. Static variables are declared outside the body of a method, but inside the class. Static variables are declared with the static keyword. You can think of static variables as having some similarities with instance variables, except static variables are declared with the static keyword. There are some differences between instance and static beyond that, though. Static variables can be shared among all instances of the class. Memory allocation only happens once, which is when the class is loaded into memory. Static variables are created when the program starts and destroyed when the program ends. Most static variables are constant and declared as public, which public means being available to all classes, and final, which means that the value is constant and the values don't change from their initial value. So the value is always going to be the same. So you can think of the number pi, for example. It's always going to be 3.1415 and so on. When accessing a static variable outside of its class, the variables are called using the fully qualified name. So a fully qualified name is for the static variable would be the class name and then a dot, and then after that the name of the variable. So for example, we have this name of class dot name of variable, and then we have an example right here of a static variable, which is a public variable, a final variable, which means the value is not going to be changing, and then static int variable name, so it's an integer with the value of 100. All variables are assigned with a data type. There are two types of data types in Java. There are primitive data types, and then there are reference or object data types. These two data types represent the backbone of variables in Java. And you'll be seeing this pretty much throughout your programming adventure. There are eight different predefined primitive data types. Each data type holds certain size of memory. Some data types have larger memory than other data types. So for example, double data types are larger memory than Boolean data types. And you can think of data types where some data types are larger in memory than others, having a box, for example, that's in a storage warehouse. Some boxes are going to be larger than other boxes. So you can think of that in terms of a data type. So if we have a Boolean data type, that box is probably going to be very small compared to, let's say, a double data type or a long data type. That box is going to be larger than a Boolean data type box. So we have our example of different data types, and here we have the data type along with the size of the data type. So here we have a Boolean, which is only 1 bit, a byte, which is of course 1 byte, and 1 byte equals, or 8 bits equals 1 byte. So you can think of it that way. Char, which is short for character, which is 2 bytes. Short, which is an integer, which is 2 bytes. Integer is 4 bytes. Float is 4 bytes, and float is a type of number with that uses decimals. Long is 8 bytes and is also a type of integer, and double is 8 bytes. So long and double are the largest of the primitive data types. Boolean is 1 bit of information, and it only has 2 values, which are true and false. The default value of a Boolean is false, and Booleans are mainly used to track conditions within a program. So, for example, we have a Boolean of a variable named is princess and castle, and that is assigned as true. Let's try this out in the IDE. So we have a Boolean called is weekend, and that's assigned as false. So we want to output this, and when we run it, we got a message with false. Obviously this is pretty simple, but as you learn more about things like if statements or for loops and so on, you'll find much more use with the Boolean. Bytes are an 8-bit signed, which signed means can be negative or positive, integer with no decimals. The minimum value of a byte is negative 128, and the maximum value is 127, or 2 to the power of 7 minus 1. The default value of a byte is 0, and this data type it's not used much, mainly when there's a lack of memory, but these days with so much memory, you'll rarely see this data type used. So we have an example, which is byte 80s console equals 1, and if you're familiar with 80s consoles, most of the consoles up until the late 80s were 8 bits, which is of course equal to 1 byte. A short is a 16-bit signed integer. The minimum value is about negative 32,000, a little under negative 32,000 actually, or negative 2 to the power of 16, and the maximum value is 2 to the power of 16 minus 1. Just like a byte, the default value of a short is 0, and just like byte, this data type is rarely used. And we have our example right here of a short variable. Char is a 16-bit character, and it stores any character and ASCII value, but it only stores just one character. So unlike string, it can only store one character. The default value of a char is the \u and 4 zeros. So you can think of this value as a null value, or the null equivalent value for a character. Character values must be enclosed in single quotes. So we have an example where the char of last letter equals uppercase Z, and this value is enclosed in single quotes. Int data type are 32-bit signed integer. The minimum value is negative 2 to the power of 31, and the maximum value is 2 to the power of 31 minus 1. Just like the other integer data types, the default value of an int is 0, and this is the most frequently used data type for integer values, or numbers without decimals. So we have our example of int variable number equals 1 million. Long is a 64-bit signed integer. The minimum value is negative 2 to the power of 63, and the maximum value is 2 to the power of 63 minus 1. The default value of a long is 0L, 0 and capital L. So this capital L just signifies that the value is a long data type. This data type isn't used often, but it's mainly used for when a larger integer is required that the int variable can provide. So we have our example of a long variable number. Float is a 32-bit floating point number, which includes up to 7 decimals. The default value of a float is 0.0f, and this f signifies that the value of the variable is a float data type. This can also be a scientific number when you include the e to indicate the power of 10. So we have our example of 10e for f equals 100,000. The double data type is used much more frequently, and as far as precision goes, it's not quite as precise. If you're dealing with things such as money, for example, you probably want to not use this. So we have our example of a float variable number equals 1200.5f. So let's try to test out how a float works. So here we have our float number, and we're going to give it a value of 1200.5f. Then we have another float, call this number 2. I'm not very creative today. And this will be 1000.1f. Then we're gonna output this. So once we output this and then run it, we get the addition of the two variables, which is 2200.6. And notice that the f is not included in this output, so the f is not going to be the output when the command is run, just the numbers. And the same goes for long as well. The doubles are a 64-bit floating point number, and it includes up to 15 decimals. This is the most used data type for decimal values, just like ints are the most used data type for integer values. The default value of a double is 0.0d, and the d stands for a double. So an example of a double variable number is 1,500,000.0. So compared to floats, doubles are used much more. So if you need to use a data type that requires a decimal number, then use the double. Reference variables are created using the defined constructors of classes, which enable the program to access the objects for the class that it's referencing. These variables are declared to be of a specific type that cannot be changed. So for example, we can have a class called employee, animal, vehicle, and so on. Class objects and various types of array variables come under reference or object data types. And the default value of any reference variable is null. So for example, a string data type that's not, since a string is a reference data type, If it's not initialized with a value, then its default variable is going to be null. And we'll learn about classes and objects in a later tutorial. Reference variables can be used to refer to any object of the declared data type or the declared type of any compatible type. And unlike primitive data types, you can create your own classes, which then allow you to reference those classes in the form of an object. Java comes with its own classes from the Java development kit. So these are built into the Java JDK that you can then leverage with your own instead of having to create your own classes. A string is a type of reference data type, though due to its frequent use, it is erroneously mentioned as a primitive data type. So just to clear any misconceptions, if you're not aware of, string is a reference data type and it's not a primitive data type. So here we have an example of vehicle car1 equals new vehicle, and we're passing in the constructor parameter Ferrari Testarossa. So as we saw in our IDE example right here, this main class is right here is reference data type, or this main class is a reference data type. And this main variable right here is an object of this main class. So we have our assignment today for this variables and data types. So number one, what are 3 types of variables in Java? And remember, this is not data types, but variables. Number 2, list all 8 primitive data types. Number 3, is string a primitive data type or a reference data type? Hope you're listening. Number 4, write a statement that assigns a value using an integer data type. And number 5, what is the default value of a reference variable? If this video was any value to you, then please leave a comment, like, share, and subscribe. Thanks for watching, and I'll see you later.